Good morning, everybody. Thank you for registering and joining us for the Python PyTecplot Quick Start webinar. My name is Scott Fowler. I'm the product manager at Tecplot. I manage Tecplot 360, our Python API, and Tecplot Focus, along with other associated products that are part of our toolkit. Just a little bit of administration to get out of the way before we get started. We will be recording this webinar and it will be available after the webinar ends. We're going to try to get a quick turnaround on the video so you can make sure to watch it and so you don't have to take close notes. We are going to be doing some live coding. The knowledge of Python is not necessary for this webinar. We're going to try to get you started with PyTecplot in 30 minutes or less. All right, so let's get going. We're going to jump in and out of PowerPoint a little bit today, so do please pay attention. What we're going to cover today are the requirements for PyTecplot, how to install it, how to record PyTecplot scripts within the Tecplot 360 user interface, and how to play them back. We're going to show you how to modify a recorded Python script. As always, when you're recording a script, you get a lot of commands in there. We're going to show you the difference between running a Python script in what we call connected mode. So that's a way that you can actually drive the Tecplot 360 user interface with Python. And we're going to also show you running a Python script in batch mode. So that would be useful for image generation, data extraction, data generation, also running headless on, say, a cluster or HPC. We'll show you some best practices and then we'll apply those practices back to the recorded Python script and modifying that script a bit further. And then we'll also show you our GitHub repository that we've started in about the last 6 months to a year that has some handy Python scripts available out there. I would also like to note that we will be taking questions during this webinar, but I'm going to try to hold off on answering questions to the end. In the GoToWebinar user interface, there is a questions pane. Feel free to type questions in there and we'll try to get to those as quickly as possible. Okay, so PyTecplot requirements. Number one, you do need Tecplot 360 2018 R1 or newer installed. We did release our first version of this Python API in 2017. So you can run Python scripts all the way back then, but at that point it was batch mode only. What I'm showing you today with the connected mode and some of the other features that I'm going to show today do require a newer version of Tecplot 360. To use PyTecplot, it also requires a Tech Plus maintenance and support contract with us. So it is really nice to maintain your support. You get a lot of use or a lot of good capability out of our Python API. It does also require a 64-bit installation of Python. This is not a problem for most Mac and Linux users, but as I've found on the Windows side, the default download for Python has, at least in the past, been a 32-bit download. So you have to make sure to navigate to that 64-bit install of Python. We do currently support Python 2.7 and Python 3.5 and newer. You notice the asterisk there next to the Python 2.7. The Python community at large is going to be discontinuing support for Python 2.7 as of January 1, 2020. We have not yet determined our long-term support policy or our support policy for Python 2.7. But I do encourage you for all new Python projects to migrate to Python 3. We are going to continue supporting Python 3. Our typical support policy is the newest version of Python 3 and 2 releases prior. So the most current is 3.7, so 3.7, 3.6, 3.5. So that's where our support policy is. It does get quite challenging for us to support a lot of different dot releases. It's just a lot of QA and testing framework, quite a lot of load there. So those are the requirements. Now, PyTecplot is a separate install from Tecplot 360. So when you download Tecplot 360 and install, you don't have PyTecplot installed by default. It does require a separate installation using Python's pip installer. It's pretty easy. We do host all of our PyTecplot sources out on PyPy, which is the repository for Python modules. So it's a simple pip install PyTecplot. If you don't have administrator rights, you can use the -- user flag, and that allows you to install it just for you. We do have a number of notes for the installation in the PyTecplot user's manual. There is a link there that you can navigate to. If you just search in your web browser Tecplot, PyTecplot, you'll get to our documentation first thing and be able to navigate through that. So I'm going to start getting into demonstration mode here, where I'll actually start from the very beginning, installing PyTecplot, running through a couple of checks to make sure that you have it installed properly, and then we'll run through an actual workflow. So let's get out of PowerPoint mode here and bring up a command prompt. So the first thing I need to do is I need to install PyTecplot. So this is going to be pip install -- user PyTecplot. And this goes out to the PyPy servers, downloads the package, and we'll install it. So this takes just a second. Okay, we're done. So now we have PyTecplot installed. So now let's validate that we have it installed. So I'll start up the Python terminal and I'll say import Tecplot as TP. I like giving it a short alias so I don't have to type so much. And we'll say tp.version info. And this tells me that I'm running Python PyTecplot version 0.14.0. I'll make a note here about our versioning. We are going to be releasing Python 1.0 in the next month or so. And what 1.0 means, that means that all documented Python APIs are going to be fully supported, fully backward compatible. Up until this point, we've been finding some little inconsistencies in our Python API and cleaning those up, and there have been the occasional code breaking change. But we're not going, once we release Python 1.0, it's going to be fully backward compatible, fully supported for all documented functions. Okay, so we've verified that we can import PyTecplot. We can get a hold of the version information. So let's actually go into Tecplot 360 and I'll show you how to record a Python script. We'll show you how to modify it for creating images and show you some best practices. So let's get out of Python here and we'll bring Tecplot 360 over. So our goal today is going to be loading a model of the Onera M6 wing. We're going to be creating a slice at various locations along this wing, and we're going to be creating images at various stations. So you see with that original layout, I had a slice in this planar view without the wing showing. We're showing contours of pressure coefficient, and we're going to create images at each location. So just to give you a view of the result that we're looking for is we're looking for a series of images at various stations along the wing. So here's one at y = 0. Let's zoom in on this image a little bit. And then so on and so forth, down from near where the fuselage would be to the tip of the wing. So let's start from a blank slate here. We're going to record a Python script. So you see on the scripting menu in Tecplot 360, there are a number of commands. We still do have, if you're familiar with Tecplot 360, we have our macro language, and that's still a great way to deal with scripting. Python adds a lot more flexibility in that it has access to arrays, string processing, the operating system through the OS module, and etc. So let's start by recording a PyTecplot script. We're going to call it recorded.py, and we want to replace it. Okay, so let's start by loading our data file, the Onera M6 wing. First thing we want to do is we want to get this into the orientation that we're interested in. So we'll grab the rotate tool here. I pressed the O on the keyboard to set the center of rotation, and we'll get this roughly where we want it. And then we can fine tune this by going into the 3D rotate dialog and set our psi, theta, and alpha angles. So it looks like we'll go 90, 180, and 0. And as recording occurs, we don't update the screen automatically. So we'll just hit redraw. You can see that it got in place. All right, so now we have the orientation we want. Let's go ahead and add the slice. So we're going to do a constant Y plane, and we'll select the slice tool and just click. That's given us a slice. Now we want to change to pressure coefficient. So we can double click on the contour legend, change our variable to pressure coefficient. And I want this legend out of the way. So we're going to put it on the bottom of the frame. So let's make this a horizontal legend. I want to change the anchor point on that legend to the bottom left. And we're going to set the position to 5 and 5, and we'll hit redraw. And now we're colored by pressure coefficient down there. I want pressure coefficient also to go from -1 to 1. So I'll go -1 to 1, and we'll do 11 levels. That puts 0 right in the middle. Again, we'll do redraw. And finally, we want to export this image. So we'll go to File, Export. Want it to be nice and big, 1,000 pixels wide. We're going to use anti-aliasing with a super sample factor of 3. So I get a lot of questions about this. What does the super sample factor do? Basically, it's used to smooth out lines and text. A super sample factor of 3 is a pretty good number. That's the default in Tecplot anyway. Okay, and let's select a new name here. We'll just call this untitled.png. And now we have a new image out here that we just saved. Now you see that I forgot to turn off the shade layer on the wing. We'll handle that as we modify the script. Okay, so let's stop recording. And we'll hide Tecplot here and come back, and we'll just dir star.py. So we have a recorded.py, and again, that created untitled.png. So I should be able to delete this, and let's just run recorded.py. So this starts up Tecplot. It checks out a license, runs through all the commands in that Python script, and there you go, it created the image for us. So that's running Tecplot in batch mode. You notice that it happened all in the background. It checked out what we call a batch license of Tecplot 360 to load the data, run through all those commands, and create the image. Okay, let's take a look at the script, and we'll explain what's going on in this script, and we'll make some modifications to it. So the first thing it does is it imports the Tecplot module, imports a couple of submodules. You can see here we loaded the Onera wing dataset. We set the center of rotation, and here we're recording all of the view change commands. Now I did a lot of movement of the mouse, and so this is going to record every movement, every action that I did within that within the UI. So it's pretty verbose here. But you can see after I get through all of these view calls, we finally get down to where we're setting up the slice. So I'll put a couple of carriage returns here. So you see that we changed the slice to be a Y plane, show the slice, set the Y position. That happened when I did the mouse click in the user interface. When Tecplot first creates a slice, it picks a default variable. So this was the density variable. It happens to be index number 3. Now there's a very key point here that I need to point out. The PyTecplot layer is 0 based. So variable index 3 is the 4th variable in your data set. Then we changed the variable to the pressure coefficient, which would be in the UI, it would be represented as variable number 12. Here it's number 11. Then we change the legend to be horizontal, so that's vertical equals false. Changed that anchor position, changed the X and Y positions of that legend, and reset the levels, and then finally saved an image. Okay, so let's do some modification to clean this up a little bit. One of the most difficult things in getting right, especially with the 3D view, is to get the view position right. Well, thankfully we have Tecplot still up and running with the view position that we want, and we can look at the view rotate and just remind ourselves of the values here. The center of rotation doesn't matter for our script, but the psi, theta, alpha angles do. We'll just type 90, 180, and 0 in here for those values. Then view position and view distance are important values as well for the making sure that 3D view is right. So we'll just bring up this dialog and look at these values. So view position, each time we change those, it records a separate command, but we can do all at once. So we will put in the X, Y, and Z values. This is 0.5269, 114.135, and minus 0.0522. So that's the view position, and then view width, 1.62394. Then we can get rid of all these other redundant psi, theta, alpha view position commands. So that's trimmed our recorded script down quite a bit. We have our view position, we have our slice setup. We have a couple of commands here where we picked did a pick command in the UI, so that's selecting the legend. We don't need that anymore. You can see now that we have redundant variable settings, so we'll remove variable index number 3 and just use number 11. We can actually access this by name as well. I'll show you how to do that after we go through some best practices. Setting the legend position, again, we set X and Y separately, so it recorded 2 commands, but we only need 1. We'll say 5,5. We can get rid of the extraneous redraw all and export the image. So let's save this. We'll go back into the command prompt and make sure that we did this right. So let's delete untitled.ping and we'll run recorded.py. And we see untitled.png come back. Okay. And one thing we don't want to see the surface of the wing in this case. We want to see the entire slice unimpeded. So we need to turn off this shade, the shade layer. In the Tecplot 360 user interface, you would come up here, plot, shade, and just turn that off. So without actually recording a macro, let's go into the documentation and figure out what the proper command is for that. So let me bring this over onto our screen. So this is our documentation for PyTecplot. Let's just type in shade. You can see there are quite a lot of options. We have a little bit of a hint here because this is on the plot sidebar, so we can look for a plot associated with shade. So it's right here, tecplot.plot, a Cartesian 3D plot, show shade. So we'll click on this, and right in the documentation, there's a little snippet of code. So we'll just copy this and we'll put this into our script. And we want to get a handle of the active frame. We'll put that right here. And then set it to false. We'll save this. And let's go back to the command prompt. We'll run the script one more time, and we should see untitled.ping get refreshed without the wing showing. So there you go. All right, so let's jump into best practices, and then we'll come back to the script. So some of the best practices to improve runtime and improve readability, you want to hold on to handles to the frame, the data set, and the plot. Each time you call tp.activeFrame.plot, it takes a little bit of time to jump through the various function calls. You'll get some better runtime if you hold on to those handles. You can run Python in optimized mode, so that's with -O. Our Python API has a number of debugging checks in there, and it will run faster when you run in optimized mode. Most Python scripts will run faster running optimized, so be clear of that capability. We have an option called tp.sessionSuspend, and this is most important when running in what we call connected mode. I'll demonstrate this as well shortly. But this helps keep the user interface when you're driving the Tecplot 360 user interface. It helps keep the user interface quiet and doesn't update, redraw as often, so your scripts will typically run faster. If you want to access raw data, our Python layer is really powerful in that it gives you access to the raw data loaded into Tecplot 360. If you access those data arrays using NumPy, NumPy being another Python package that's very good and very quick at matrix manipulation and array manipulation, you'll have faster access to that data. To improve reusability of your scripts, instead of using variable numbers and zone numbers, you can use variable names and zone names. So in this case, we can access the wing zone by using wing with a wildcard, wing star. Same sort of thing with variables. So here I'm asking for the y values from the wing zone. I'm asking for the min max of y, and we'll show you how to use this. So keep these in mind, and we'll do a little bit more modification of that script. Okay, so the first thing, we want to replace all of these tp.activeFrame.plot calls with holding on to a handle. So we'll do a search and replace tp.activeFrame.plot and just replace all of those with a direct call to plot. Now we need to hold on to a handle here, tp.activeFrame.plot. Okay, so now we have a bit more shorthand notation here. A couple other things that we can do here. We can access variables by name. So here, instead of variable index, we'll just assign it to a variable, and we'll say tp.activeFrame.dataset.variable pressure coefficient. Okay, so this is now giving me access to the pressure coefficient variable in the currently loaded data set. So a little bit of shorthand there. Up here where we load the data set, when recording a Python script, the read dataset command that Tecplot has is quite complex. It's string based, so it's very difficult to translate to a pure Python form. In our documentation, we do have load commands for many file types. So let's just type load. So here you can see that we have load fluent data, fvcom, load Tecplot. So this is the one that we're interested in here. Load Tecplot, it can take a list of file names and a number of other optional commands. In this case, all we need to do is pass one file name. So again, you can see the documentation is quite useful. So let's replace this with tp.data.load Tecplot. We'll just use this file name. Get rid of this trailing backslash and close the parentheses, and then we can delete these 5 or 6 lines. Okay, one of the handy things here is that the load Tecplot command also returns a handle to the data set. So we'll just grab the data set directly, and then we can replace this bit down here with the handle to the data set. Okay, so we're well on our way. What we want to do again is create a slice at various stations along this wing. So what we'll do is we'll here create a loop. We'll say for Y position in, we'll use a NumPy command here called linspace. So this is going to give me a regularly spaced set of values, and I don't know my Y min and Y max values yet, but we'll just fill this in, Y min, Y max, and let's say that we want 10, and then we're going to put the adjustment of the slice position down within this loop. Need to make sure to tab these in and replace this with Y pause. Okay, so how do we know the min max? Well, we could certainly hard code that by going into looking at Tecplot, going into the dataset information dialog and saying, okay, well, my wing zone, I have the Y variable, and I know my min max is from 0 to 1.2. But if I want to use this script for other data sets that may have a different min max for Y, this is where it gets pretty handy to have the Python API. So let's, in here, we'll ask the data set for the wing zone, dataset.zone wing star, so I can do a wildcard search. Then we'll ask for the Y min and Y max. We'll say wing.values for the Y variable, min max. So now I don't have really any hard-coded values in here that are associated with the data set. Okay, pressure coefficient, we've hard-coded the range from -1 to 1, but that's fairly typical for that variable. Okay, and exporting the image, well, we want a different image for each position. So let's encode the Y position here. So we'll say .format Y pause. So this is now going to create untitled with some numeric following it. Okay, so we'll save that, and we'll cross our fingers that I typed everything correctly here. Recorded.py. I should have run this with Python-O optimized mode. Aha, so NP is not defined, right? So I used this NumPy call, np.linspace. I need to make sure to import that. So I'll say import NumPy as NP. Say Python-O. Okay, and you can see it's going through and generating these images at the various stations that we've asked for. Okay, so that all worked in batch mode, so that's really great. Now let's show you running this script connected to Tecplot 360 and show you what that looks like. Let's do a new layout. So we have no data loaded, and we'll go into the scripting menu, and we're going to tell Tecplot to accept connections from Python scripts. So we'll say toggle on accept connections. Our Python layer communicates with Tecplot 360 using scripting. So this is port 7600, and we'll go into the script. We'll just uncomment this one line, tp.sessionConnect. We'll save that, go back into the command prompt, and you can see that it's now updating as we go along. So it's doing a redraw at every new slice location. Okay, one of the other best practices that I mentioned is this tp.sessionSuspend. So we're going to put everything here in a tp.session_suspend context, and we'll tab everything in here. And then if we rerun this within Tecplot 360, the user interface won't update during all of this, and we'll get our images out faster. Okay, so that's running Tecplot in connected mode. That's also running it in batch mode. We've gone through our best practices of accessing zones and variables by name, holding on to handles. In this case, we're holding on to handle to the plot for faster access. Okay, I realize we're getting close to the 30-minute limit on this webinar. We're almost done, so let's just move on to the last couple of slides. So that's the end of, effectively the end of the live demo. I'm going to show you one more very quick live demo here at the end. We do have a GitHub repository. If you just search for Tecplot GitHub, it'll take you right there. We have a number of interesting Python scripts here that can be used as examples. You're more than welcome to download these. It's all under MIT license, so we don't have any intellectual property invested in these. We want you to use them and be successful with PyTecplot. We have some interesting ones. Parallel Image Creator is one of my favorites. In Tecplot, you save a layout, you run this, pointing to that LAY file, and if it's a transient data set, you can create images from that data set in parallel. We have one that can compute and display a histogram, which I'll demonstrate. Computing a time average, quite useful. Under data conversion, we've started a Python wrapper for our TecIO library. TecIO is our library that produces binary Tecplot data files. We also have some examples for how to read and convert some of the VTK XML-based formats in there. So that's a pretty interesting location. So let me just jump back into Tecplot 360 and show you that histogram Python script. So the histogram Python script I've registered right here on my quick macro panel. So this is pretty great. I can just double click. It wants to know what variable do I want to do the histogram for. So we'll say pressure coefficient. And how many bins do I want on my histogram? Let's say 11. And this will actually read the variable values and compute the histogram and display a plot. And now I have that plot right here in the user interface. So pretty handy to be able to register your Python scripts also with the quick macro panel. And if you're interested in doing that, just give our support staff a call and we can show you exactly how to do that. Okay, final couple slides of PowerPoint. And then we'll let you go for the day. So we have a lot of users who have really embraced our Python API and Tecplot 360. These are some of my favorite quotes. This is a game changer for me from a Boeing engineer. That was specifically in reference to that parallel processing of images. He had very large data over a long time series, and he was able to get his answers back 6 or 10 times faster by running Python in batch and parallel and using some of those best practices that we talked about. Our IT staff is one of the best in the industry. I've heard this over and over again. Our tech support staff is available in the United States, 6:30 a.m. until 5 p.m. Pacific time. We also recently acquired our German distributorship. So now they've joined the Tecplot family, and now we do have tech support available in Europe. They've been providing support for our European customers for years, and we're very happy to have them in the Tecplot family now. So if you're over in Europe, you can contact the group over there as well. So with that, I appreciate you watching today. Please, if you have any questions, put them in the question and answer field. Here are a couple of links. Again, just searching in your web browser is probably going to be the best way, so you don't have to remember these links, but just search for PyTecplot, search for Tecplot, PyTecplot, Tecplot GitHub, and you'll find the answers that you need. So with that, I'll open it up to questions. I'll give you just a couple of seconds to type those in. So one question that we do get quite a bit is there are organizations that have multiple versions of Tecplot 360 installed, and how does PyTecplot work with multiple versions? Well, when you're running in connected mode, you can run, because you're connecting to a port, whatever version of Tecplot you have up and running, you can connect right to that version and it's going to use that version. If for some reason you need to be using an older version of Tecplot 360, because we do rely on the installed version of Tecplot 360, you need to make sure that your path environment variables are set properly. So on Linux, that would be LD library path. On Mac, that would be DYLD library path. And on Windows, that would be the path environment variable. All of that's in the user interface. Okay. Looks like no other questions. Feel free to, if you do have a question after this, after viewing the recording, contact us at support@tecplot.com. Again, our support staff is pretty great, so they're going to be available. So with that, thank you very much. I'll leave the webinar running for just another couple of minutes in case you do have questions.